Vectors. A vector quantity is any quantity which has both magnitude and direction. Example. So some examples of vectors, we could have displacement, acceleration, velocity, momentum, force, weight, and so on. Talking about the vectors, it is necessary also to consider the scalar quantities. A scalar quantity has only magnitude but no direction. And some examples of scalar quantities are time, speed, distance, mass, area, pressure, and etc. Let us talk about some notation of vectors. Free vectors are denoted by a pair of block letters and an arrow. For example, AB. Generally, for the vector AB equal to a, small b, the small a and the small b are said, that is A and B are said to be the components of the vector AB. Having talked about the notation of vectors, let us also look at the representation of vectors. In the representation of vectors, we have the column or component form. That is A, B. So A, B, whenever you see a vector in this format, it means that vector is in component form or it is in column form. For example, we have AB equal to 1, 2. This vector AB with the components 1, 2 is in column or component form. Again, we could have vectors in standard basis form. So for the vectors in standard basis form, for instance, you write A vector AB, which is 1, 2 in standard basis form. Generally, IA, we have AI plus BJ. So it is going to be AB, you have I plus 2J. That is, we introducing the dimensions into it. So the I direction and then the J, that is when we're talking about the Cartesian plane, right? So in 2 dimensions, we have the I and the J in the Cartesian plane. We also have another one, which is the magnitude and bearing form. And an example of that could be maybe if we have a vector OB, which is equal to 3 kilometers and then 0 degrees, then this one is a vector which is represented in the form of the magnitude and the bearing form. Now, having talk about the representation of vectors, then let us also consider some types of vectors. We have one, the zero vector. Now, for the zero vector, it is a vector with zero components, right? So a vector with zero components. That is, I could have 0, go to 0, 0, or it could be 0i plus 0j. And a zero vector has 0 magnitude. Now, our next example we want to talk about is the equal vectors. Equal vectors. Now, for instance, if we have vector A equal to x1, y1, and vector B equal to x2, y2. If I say these two vectors, vector A and vector B, are equal, then it means vector A is equal to what? Vector B. Now, if this is true, then the components of vector A, which is x1, y1, will also be equal to the components of what? Vector B, which is x2, y2. If this is also true, then we could say x1 is equal to what? x2. And y1 is equal to y2. So for the equal vectors, if I'm given vector A equal to x1, y1, and vector B equal to x2, y2, and I say these two vectors are equal, then the components of vector A, which is x1, y1, is equal to the components of vector B, which is x2, y2. If this statement is true, then we could say that x1 is equal to x2, which we have here, and also y1 equal to what? y2, which is also here.